Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Hi, Assalamualaikum. We from College Matrikulasi Melaka would like to present Physics Subtopic 12.2 Thermal Expansion daripada saya, Nur Ismayuni S15P5. Okay, today we would like to define coefficient of linear, area, and volume thermal expansion. Beside that, we'll also solve problem related to thermal expansion of linear. Definition of coefficient of linear thermal expansion, alpha. It defined as the change in length of a solid per unit length per unit rise change in temperature. The unit for the alpha is degree Celsius -1 or Kelvin -1. If the length of the object at a temperature T is L, so we can see that delta L equal to L final minus L initial. Substitute delta L as alpha times L initial times change in temperature. The length L in the equation could be the length of a road and the side length of a square plate. It also could be the diameter or radius of a hole. Definition of coefficient of area thermal expansion, beta. It defined as the change in area of a solid surface per unit area per unit rise in temperature. The unit for the beta is also degree Celsius -1 or Kelvin -1. The area of the surface of object at a temperature T can be written as area equal to area initial times 1 plus beta times change in temperature. For isotropic material, the area expansion is uniform in all directions. Thus, the relationship between alpha and beta is beta equal to 2 alpha. Definition of coefficient of volume thermal expansion, gamma. Gamma is defined as the change in volume of a solid per unit volume per unit rise in temperature. The unit for the gamma is also degree Celsius -1 or Kelvin -1. The volume of an object at a temperature T can be written as volume equal to volume initial times 1 plus gamma times change in temperature. For isotropic material, the volume expansion is uniform in all directions. Thus, the relationship between alpha and gamma is given by gamma equal to 3 alpha. Next, we'll proceed to problems related to thermal expansion of linear. A steel is 40 cm long at 20 degrees Celsius. The coefficient of linear expansion for steel is 12 times 10 to the power of negative 6. The increase in length and the final length when it is at 70 degrees Celsius will be. So, from the question, we will get some information that the change in temperature delta T will be 50 degrees Celsius, whereas 70 degrees Celsius minus 20 degrees Celsius. The original length is 40 cm. The coefficient of linear expansion for steel, alpha, equal to 12 times 10 to the power of negative 6. So, we need to find the change in length and the final length. For the change in length, delta L, we will use delta L equal to alpha times length initial times change in temperature, and we will substitute the value. Lastly, we will get 0.024 cm. Next, we'll find the final length, which is final length equal to length initial plus change in length. We'll get 40.024 cm. That's all from me. Thank you.
Assalamualaikum and hello everyone. My name is Fatin Shazwani binti Ahmad Zamri. So in this video, I will share with you guys how to solve the problem that related to the thermal expansion of area and volume subtopic 12.2. A simple question. A solid plate of lead is 8 cm times 12 cm at 15 degrees Celsius. What is the change in area and the new area of the lead plate if the temperature increased to 95 degrees Celsius? So the coefficient of linear expansion of lead is 29 times 10 to the power of negative 6. So the one that I highlight with purple color is the information given, and the yellow one is the question that we need to solve. First of all, we need to draw a plate with the length is 12 centimeter and the width is 8 centimeter. And the area is 96 centimeter square. Okay, 96 centimeter square. So to find the new area and change in area, we must find the new length and new width first. So to find the new length and new width, we must use the formula. Delta L means length is equals to alpha L naught times delta T. So the alpha is the coefficient of linear expansion of lead. So just substitute 29 times 10 to the power of negative 6 times L naught is 12 times change of t, which is 95 minus 15, and the answer is 0.0274 centimeter. And the new length is, I put as L new, is 12 plus 0.02784, and the answer is 12.02784 centimeter. Next is, we need to find the change of weight. Change of weight is equals to alpha times with naught times delta t. So the coefficient is 29 times 10 to the power of negative 6 times width is 8 just now, and the temperature 95 minus 15, and the answer is 0.01856 centimeter. Okay, so for the new width is 8 plus 0.01856 is equals to 856 centimeter. New area is equals to L new times width new. Okay, so L new just now is 12.02784 times width new is 8.01856, and the answer for the A new is equals to 96.446 centimeter squared. Okay, and now we can find the change of area. Change of area is A minus A, no, sorry, A no. So the A just now is 96.446 minus A naught is 96. Okay, the answer is 0.446 centimeter square. So this is the final. Let us move to the next question. Okay, the second question is, a rectangular solid vase has a coefficient of volume expansion of 56 times 10 to the power of negative 6. The dimension of rectangle are 1.5 meter times 1.8 meter times 2.4 meter at 10 degrees Celsius. So what is the change in volume and the new volume if the temperature increased to 90 degrees Celsius? So the answer wants us to find change in volume and the new volume. Okay, first we need to calculate the V note. So V note we can get from this. V note is equals to 1.5 times 1.8 times 2.4, and the answer is 6.48 meter cube. Okay, we know. Okay, so to find the change in volume, we must use the formula. Delta V is equals to gamma times V naught times delta T. Okay, so gamma is coefficient of volume expansion, which is 56 times 10 to the power of negative 6 times V naught is 6.448 times change of volume, change of temperature, 90 minus 10, and the answer is 0.029 meter cube. Okay, so he got the change in volume. Okay, next step, to find the new volume, we can just use the formula. V new is equals to V naught plus change of volume. So V naught just now is 6.48 plus change of volume is 0.29. Okay, so the answer is 6.509 meter cube. So this is the final answer. This is the last question. If a 500 ml glass beaker is filled to the brim with ethyl alcohol at a temperature of 5 degrees Celsius, how much will overflow when its temperature reaches 22 degrees Celsius? So given this coefficient of volume expansion for ethyl alcohol is 1.100 times 10 to the power of negative 3. Okay, to find the overflow, we can just straightforward use this formula, which is change of volume equals to gamma V naught times delta T. So gamma is 1.100 times 10 to the power of negative 3 times V naught, which is 500 ml, and change of temperature 22 minus 5. Okay, so the answer is 9.35 ml. So this is the answer. Thank you for watching. I hope this video can help you to understand more in a subtopic and how to solve the problem that related to the thermal expansion of area and volume. That's all from me.